This is chapter 2, functions. Here we have question number 9. Let's see, the set of all complex numbers. A function f from c to c is defined by fx equals x cube. So we have the function from complex number to complex number, and the function is also given, which is x cube. We have to find out f inverse 1. F inverse 1. So let me write it. This is fx equals x cube. So f inverse 1 we have to find out. F inverse 1. Let us assume it to be x. Generally we take it as y. You will see in one upcoming question. But because we don't have any x on the left hand side, so we can just put it as x. So f inverse x. So just take f inverse on the right hand side. Fx will be equal to 1. You have x cube as fx, x cube equals 1. So x cube minus 1 equals 0. Now assume this 1 to be 1 cube. So we have x cube minus 1 cube, a cube minus b cube. So this will be a minus b, a square plus ab plus b square. So x square plus x plus 1. Now what do you see here? Because this range and domain both are complex number, so we have to write this x square plus x plus 1 in terms of complex values. We know that omega 1 plus omega square is 0. Omega cube equals 1. Please recall it from the complex numbers discussion. And omega has a value 1 plus minus I under root 3 by 2. This also we know by complex numbers. So we can write this x square plus x plus 1 as x minus omega into x minus omega square. So when we multiply it, you will get x square plus x plus 1 only. Because these are going to come in the other questions, so I am just multiplying and trying to demonstrate. So x square minus x omega square minus omega x plus omega cube. So we have x square. Here you have omega cube. And I told you omega cube is equal to 1. X square. Here omega cube is 1. So what do you get inside? So I am taking x common from here, minus x. What do you get inside? Omega plus omega square, or omega square plus omega. So this is what you got. And I told you already 1 plus omega square is equal to 0. So omega plus omega square will be equal to minus 1, negative 1. So negative 1 you put it here, negative becomes positive, it will be x square plus x plus 1. You just have to keep in mind x square plus x plus 1 can be written as x minus omega into x minus omega square. So what do you get? X minus 1 into x minus omega into x minus omega square equals 0. Now put all 0, so x equals 1, x minus omega equals 0, so x becomes omega, and this becomes x equals omega square. So what are the values of this x? X was assumed to be f inverse 1. So f inverse 1 is going to be 1 omega and omega square. Okay. So this is question number 10 now. Okay. So let f be a function from c, again the set of complex number, to itself given by fx equals x cube. So fx is given as x cube. Write f inverse negative 1. So f inverse negative 1, this is going to be equal to x. So f inverse minus 1 is x. So fx is negative 1 here. Fx is already given. It is given as x cube. So equate negative 1 with x cube. What do you get? X cube plus 1 equals 0. Now assume it to be 1 cube. Now we have to apply the formula of a cube plus b cube. Now please remember this, because we are going to use in the another question. So a cube plus b cube is a plus b, a square plus b square minus ab. So what do you get? A is x square minus x plus 1. So in the previous question I told you how to write x square plus x plus 1. Similarly, we are going to write for x square minus x plus 1 as x plus omega into x plus omega square. So when you multiply, you will definitely going to get x square minus x plus 1, because 1 plus omega square is equal to 0 and omega cube is equal to 1. This is what you are going to get. So I'm not multiplying it. When you multiply it, you are going to get that only. Just apply those identities I told you. So just I am putting it as 0. This gives you x equals negative 1. This gives you x equals negative omega. This gives you x equals negative omega square. Okay. So f inverse negative 1 is equal to negative 1, negative omega, and negative omega square. Okay. So 11th question. Let f is R to R be defined by fx equals x to the power 4. Write f inverse 1. So this is not a complex number question. Please remember R to R. So what do we do? F inverse negative 1 we have to find out. So just write it as x. Fx is already given as x to the power 4. So f inverse, see f inverse, and this f inverse minus 1 equals x. So you get fx as negative 1. It is 1, sorry. I'm so sorry. It's not negative 1, it's plus 1. It's 11th question. So it's f1. So fx is equal to 1 here. Now just equate it to x to the power 4. So x to the power 4 is equal to 1. So you get x to the power 4 minus 1 to the power 4 equals 0. And this is, you can write it as x square whole square minus 1 square whole square equals 0. So now this is a formula of a square minus b square. A is x square here, b is 1 square here. So a square minus b square. A minus b plus b you are going to get. So x square minus 1 and x square plus 1 equals 0. So this becomes x square minus 1 square. Again we will apply the same formula. This will be x minus 1 into x plus 1 equal, we have x square plus 1 also, equals 0. Now this gives you x equals 1 when you put it equal to 0. X plus 1 will give you x equals minus 1. And this gives you x square equals minus 1. That is x is equal to under root minus 1. And that is not in your real number. Please remember the set was real to real. So we just don't take it. Okay, f inverse negative 1 will be, because x is actually f inverse 1. So f inverse 1 equals 1 and negative 1. Question number 12 here. Okay, now again this is a complex number question. So this is f is c to c is defined by fx equals x to the power 4, right? F inverse 1. So this question and the previous question are exactly same. The only difference is of the domain and range. Previous was real number. Here is complex number. Okay, just take it here. You have to do exactly same till the point we get x minus 1, x plus 1 and x square plus 1. Because it was a real number, I just left x square plus 1 equals 0. I said that it will not come in real number. But when you talk about a complex number, I'll start from here only. I hope you got the idea. Everything is the same as the previous question. The time we reach x minus 1 into x plus 1, x square plus 1 equals 0. What do? This gives you 1 and minus 1. We have already, this answer was already in this question. Negative 1, 1. But here x square plus 1 can be written as, because this 1, see, I square is equal to minus 1. So when you include I square here, that is minus 1, you have to include a negative also. That is I square is equal to negative 1. So you can write this 1 as 1 into minus 1. 1 into minus 1. I am including minus 1 now, introducing. So in place of minus 1, I am putting I square. So this is 1 into I square. But since we have already put minus 1 by ourselves, we have to negate it by putting a negative 1. So negative. So x square minus I square it will be. So x square minus I square will be what? X minus I and x plus I. So x minus 1 into x plus 1, x square minus I square will be x minus I into x plus I equals 0. So you get x equals 1 here, you get x equals minus 1 here. And from x equals minus 1. And from here you get x equals I. From here you get x equals negative I. So this is the solution. I square equals minus 1. That is I equals under root minus 1 we have used. So f inverse 1 is equal to negative 1 plus 1. Along with this you are going to get this I and negative I. Question number 13 here. So if R to R is defined by fx equals x square, find f inverse negative 25. So again, the domain range is real number, basically domain and codomain. So f inverse negative 25, just put it equal to say some x, because it is r to r. You'll see this won't come in the real number. This is f inverse negative 25, just put it as x. So you get fx equals negative 25. So fx is equal to x square, just x square equals negative 25. So since it is a real number, x square equals any number which is negative is not permissible in this real number. So x square equals minus, you remember x square plus 1, I negated it in the previous question. So you will not even take it, because this doesn't come under the purview of the real number range. Because this under root minus 25, you have to go to the complex set, which is not in the, neither in the domain nor in the codomain. So just take it as it is an empty, the empty result. Now question number 14 here. So we have if, okay, now this is a complex number problem. So you have to apply the complex number stuff here. So f is from C to C is defined by fx equals x minus 2 whole cube. Write f inverse negative 1. So f inverse negative 1 here. Negative 1. So f inverse minus 1 equals x. Minus 1 will be equal to fx. And fx is already given as x minus 2 whole cube. Put it here. X minus 2 whole cube is equal to, this is as negative 1. Okay. Now, so what do you see? We have already done in a previous question. This is y cube equals minus 1, or x cube equals minus 1, x cube plus 1 cube equals 1 kind of solution. We have already, I'll just take you back and I'll show you. This x minus 2, if you take it as some variable, it say y, so y, just take it as y cube equals 1. So y cube equals minus 1, it is simply equal to y cube plus 1 cube equals 0. So that is the formula of a cube plus b cube. So x cube plus 1 or 1 cube or y cube plus 1 cube, the same result will be there. This already we have done. It is negative 1, negative w, negative omega and negative omega square. We have already solved it. You have to do it till here by yourself. Okay, because it has been already explained. So basically x minus 2, if you assume it to be some variable, it will be going to give you result. Y came as, I am assuming y as x minus 2, y came as minus 1, minus omega and minus omega square, right? But y we assumed as x minus 2, so you have to replace y with x minus 2. So x minus 2 equals minus 1, x minus 2 equals minus omega, and x minus 2 equals minus omega square. So what do you get from here? X equals 2 minus 1 is 1. So you get 1 here, and from here you get x equals 2 minus omega. From here you get x equals 2 minus omega square. So this is the solution. So 1, 2 minus omega and 2 minus omega square will be the solution. Question number 15 here. This is a real number set. So f is from R to R is defined by fx equals 10x minus 7. Then write f inverse x. So 10x minus 7. So just put fx equals 10x minus 7. Now, you cannot put this on the right hand side. See, f inverse x is equal to, you cannot put it as x. As I already told you that y is equal to fx is our original function and x equals to fy is our inverse function. So we have been putting f inverse 1 minus 1 as x up till now, but that's not fair, because y equals fx is our function, x equals fy is our inverse. So you have to put a y here. We haven't done it just for the sake of convenience, but we have to put y. So fy becomes x, fy becomes f. This is the inverse actually. So you have to put this. This is the actual result for what you get and you should get. So because just we wanted to see the expression in terms of x, that's why we put it. Now fy will be equal to 10y minus 7, because you are going to put y here. 10y minus 7 x. So what is y going to come? 7 goes here. So 10y will be equal to x plus 7. y will be equal to x plus 7 by 10. This is your y, which is actually f inverse x. So f inverse x equals x plus 7 by 10. This is your final result. Okay. Okay, this question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.